carrying on with this electricity worksheet. So what it is exactly like the other questions, right? You've just got to make sure you put all these components in. Right, so let's start with our 12 volt battery. Remember what we said, a cell is single. That's a plus, that's a minus. A cell is single, because this could come up. If you have lots of cells, you end up with a, that's plus minus, you end up with a battery. So let's start drawing that. So what we can do is we can do, I think it's better to draw more than one cell. Right, always put the ammeter, right, I'll tell you what we'll do is we'll put the switch first. This is how you normally see it on so at the moment I'm going to put it open. So that's the switch done. Then what I'm going to do is I'm going to put the ammeter. That's going to measure the current. Then I'm going to turn the corner. So let's do that. So that's done. That's done. What I need to do is, if I just do that for completeness sake, so those are those two components done, and we've got rid of the switch. Now what we do is let's put the 60 amps, silly person, 60 ohm resistor. So there's the resistor. Put 60 ohms. Right, that's that done. And then what we'll do is we'll use this variable resistor here to vary the voltage across the components. Let's do that again. Right, okay. So what you do is you have that, and that's your variable resistor. Right, then we turn the corner. Right, okay. We don't need a filament lamp. Right, now that's that bit done, and now we just need, so we've got the connecting wires, we just need a voltmeter, and that normally just goes across. Let me change that color if it makes a difference. Across the resistor, so it has to go in parallel, not in series. And that's that done. So what you want to do, look at this carefully. Let's do it with that. Right, this here, the ammeter is in series. The voltmeter is in parallel. There you go. Right, that's that done. So we've done the connecting wires as well. Right, describe a suitable method the student could use for this investigation. Right, let's make some room. Let's make it smaller, move up. Right, so what you do is, first of all, measure the voltage and current. Then you vary the voltage across the resistor. So let's have a look at this. Let's get rid of all. Can we get rid of them without killing anything? Okay, so let's just do it this way. So what we do is we now need to change the voltage across this component. And we do that by increasing the voltage. So there's a little dial on here, and you just move it whichever direction you want to vary the voltage across. By the way, vary the voltage across the variable resistor. That will then change the voltage across the 60 ohm resistor. That's all we're doing, right? So change, alter, vary the voltage across the variable resistor right. Take the readings for voltage and current using the voltmeter and ammeter again. Right, you do that for a series of readings, then repeat each voltage reading. At each voltage reading, remove anomalies and average out at each voltage. Right, now once you've done that, they want a few more experimental details. So right, because temperature affects resistance, yeah, so switch off between between readings to stop components, components, let's say components and wires, components heating up. Or you can just turn them off, let them cool down. Right, what else is there? This is another safety thing. So do not use full range or the high end range of voltages so current does not go too high. Overheating, not too high, overheating equipment. So you could cause, well, it's unlikely. You're more likely to blow the fuse than cause a fire. Right, okay, that's that done. Now we're on part 3, complete the current voltage diagram. Right, so we know we know, where did I put it here? V equals I R, right? We know R is 60. So we know the voltage is 12 volts. So we now need to work out I. So what we do is we do 12 divided by 60 equals I. And then that will equal 1 over 5, which equals 0.2 amps. So we know at 12, right, what I'm going to do is I'm going to cheat. I'm going to pretend I've got a ruler and I've drawn a straight line to there. Right, that's it. Yeah, 12, 0.2, straight line. And it, right, this is what this said on the mark scheme. It passes 0, 0 there, and it's a straight line. Right, now we've got to do this one. So these student repeats, but with a 120 ohm resistor. So let's do that again. Let's do it over here. V equals I R. V still 12. We're trying to work out I, and we know R is 120. So it's 12 over 120 equals I. So that works out as 0.1 amps. So a resistance of 12 volts, 0.1 is down here. We'll try to draw a straight line there. Right, straight line, lower gradient, it'll have half the gradient, and right, okay. Right, so that and that will get you your marks, but if they want a description, we can write that. Right, compares, right, okay. It is a straight line. It goes through the origin. The origin, which is just simply 0, 0. It is half the gradient, so it's half as steep. Why? Because the larger resistance will, because the larger resistance will mean a lower current. Okay, so right, that's that done. Next question. Right, okay, same idea. What, 15 minutes? Okay, we can squeeze this question in. Can we squeeze this question in? No, we'll put them separate actually. Right, call it quits on this one.